CAN bus is a message-based communication protocol. What that means is that it's a set of rules that enable distributed electronic control units, sometimes called CAN nodes, to talk to each other on a network. There are lots of reasons why you might choose to use CAN bus for this type of communication instead of something like Ethernet or serial or manually sending digital high and low pulses over individual conductors. Number one, CAN bus is incredibly simple to set up. You only need to run 2 wires between all of the nodes that you'd like to talk to each other. Not one individual wire for every potential signal you might want to send, like if you were trying to communicate these things the old school way. It's also incredibly robust and does really well in electrically noisy environments, like you might find on an electric car or you might find in a manufacturing facility. CAN is also relatively easy to upskill in and then implement because a lot of the complexity gets abstracted away in the off-the-shelf hardware that we use. Finally, despite being a relatively straightforward, relatively simple, relatively easy to understand protocol, it's still pretty feature-rich. It provides, for example, functionality around message prioritization and arbitration, and provisions functionality for request messages where one ECU can poll another for information. Before we can go any further, there are 2 key facts that you need to understand about a CAN bus network. Number one, these networks are what we call multi-master, meaning that any ECU on the network, anyone who's connected to the CAN bus, has the potential to send a message. It's not like a master-slave system that you might have in other communication protocols. In CAN, everything is awfully democratic and equal. Secondly, a CAN network is what we call multicast, meaning that every ECU on the network receives every message that's been broadcast. It's not like ECU A can only talk to ECU B. In CAN bus, one node, ECU A, will broadcast to all of the nodes on a network. This is actually incredibly powerful. You don't need to repeat a message if it has to go to multiple destinations. And oftentimes in CAN, we are trying to broadcast one bit of information to lots of participants. Now, the original CAN standard was developed all the way back in the 1980s and was formalized sometime later into an ISO standard that is still followed today. But over time, as lots of potential other use cases for CAN have emerged, so too have variations on this original standard. There are, for example, CAN standards for working in situations where you need galvanic isolation, and there are CAN standards for working with cars specifically. There are quite a few of these variants, and we're not going to touch on them here. This module is going to be focused around the original recipe CAN standard called CAN 2.0 or Classical CAN. This standard is largely described in 2 parts, a physical layer, which relates to the hardware and the electrical signals and some of the requirements that are put on the participants of a CAN network. And secondly, a so-called data link layer, which corresponds to the format that you use for your messages and the way that things like arbitration are handled. We're going to largely follow that format in our dissection of this standard. We'll start with the physical layer and then move on to the data link layer. And by the time that we're done here, you should be in a good position to tackle the capstone project, building your own CAN network. So without further ado, let's get started.